Welcome back to Mr. Wernau Does Your Homework. We're going to continue our discussion with second FTC. This is worksheet number 3 for us. So the second question we'll take a look at, it says, suppose f prime is a continuous function and that the value at 1 is 13 and the value of the function, not the derivative, is at 10 is 7. We want to find the average value of f prime over the interval 1 to 10. So of course this is our average value function. So we know average value is our rule for here. We're looking for the average value of f prime. So it's going to be 1 over b minus a of our integral a to b f prime of x dx. Remember, it's the average value of f prime. So solving this one, if I set this up, well, we got our a and b. There's our a, there's our b. So this would become from 1, 10 minus 1, from 1 to 10, f prime of x dx. Now, just using our fundamental theorem, this becomes 1 over 10 minus 1 times f of 10 minus f of 1. Ah, they gave us those, right? So we're going to get 1/9. F of 10 is 7. F of 1 is 13. So that becomes negative 6 over 9, or negative 2/3. Very easy to do. Now, so easy and so fast, let's take a look at question 3. We're going to take a look at only 2 parts of question 3, A and B. So for question 3, they give us a differentiable function between negative 4 and 4. And then they say g of x is this area. Again, remember, this is an area problem between negative 4 and 4. The first question says find g of negative 4. Well, that's not going to be too hard to find. G of negative 4, my rule says to take the area from negative 4 to negative 4. Oh, wow. F of t dt. And we know that's just going to be 0. Therefore, we can say g of negative 4 is 0. The next one says find g prime of negative 4. Well, g prime of negative 4, well, this is our derivative. So this is our, we have to take the derivative, so we've got to find g prime of x. Well, our rule says everywhere there's a t, we just plug in an x. This is our second FTC, equals f of x. So therefore, g prime of negative 4 is just f of negative 4. So we're looking at the value at negative 4. So at negative 4, the value there is 2. Therefore, g prime of negative 4 is 2. I wonder what else we could do. They gave us we got a point at negative 4. We got the slope at negative 4. Man, what if they asked me to write a tangent line at negative 4? Well, we would get y minus 0 equals 2x plus 4. So now I can even write a tangent line. How much fun is that? I know you guys think, man, that's so much fun. All right, so let's take a look at another problem for us. Number 4 always causes a little bit of trouble with some people right here. So I do want to take a look at this one with you. It's mainly this x squared right there that causes the trouble. So for 4a, they are asking us to find f prime of x. This is our second FTC. So I'm going to do this a little bit slow. We're going to get f prime of x. We take the derivative of f. We also have to take the derivative of our integral. That's where we get the second FTC from. And that becomes t squared, of course, plus 8 dt. And when we take the derivative, we're going to use our shortcut rule. Everywhere there's a t, we're going to replace it with x squared. So that's going to give me the square root of, this becomes x to the 4th plus 8 times the derivative of x squared, which becomes x to the 4th plus 8 times 2x. And there is our final derivative right there. I'll let you guys go and do part B. All you got to do is plug in a 1 there. But let's go and take a look at part C. We want to find the second derivative. All right, now the second derivative, I have to look here. So of course this is going to be our product rule. Now of course there's also a chain rule there. So I am going to rewrite my first derivative as x to the 4th plus 8 to the 1/2 times 2x. So the second derivative using my product rule, we're going to get the first, which becomes x to the fourth plus 8 times to the 1/2 times 2 times the derivative of the second, plus the second times the derivative of the first. 1/2 x to the fourth plus 8 to the negative 1/2 times 4x cubed. There's my chain rule, right? There's my chain. Don't forget chain rule. And of course, we don't like negative exponents. I can simplify a little bit. F double prime is going to equal 2 times x to the fourth plus 8 to the 1/2 plus this becomes 4x to the fourth over x to the fourth plus 8 to the 1/2. You can simplify that if you want. I'm not a big fan of that. I would leave it. And then you guys can go and do part D. All you have to do is plug in a 1 and you can get that. Now, of course, what else could I ask you? Where is this function increasing at 1? Is this function concave up at 1? So we can ask you lots of other different types of questions from here as well. Okay? All right, the next one I want to take a look at is number 5. Number 5, it asks if f is defined by this integral, on what interval is f decreasing? Decreasing. This is our first derivative test. In other words, sign charts. Oh my gosh, we love sign charts, don't we? So for number 5, I have to take the derivative. And my rule says everywhere there's a t, I'm going to plug in an x. I will get x times x minus 2 cubed. So of course we know we have to get our critical numbers, set this derivative equal to 0. And we get our critical number to 0 and 2. When you do your sign charts, f prime and f, 0 and 2. Now the big mistake people make, they think this negative 5 is a domain restriction. It is not a domain restriction. It's just a starting point for us. We can have values less than negative 5. So we ignore that negative 5 when we're looking at the derivative. Notice when we took the derivative, we got rid of that. That became 0. So there's nothing there. So we don't have to worry about that. That's negative 5 is not a domain restriction. So I pick numbers less than 0. So if I plug that in, I have a negative. And this is negative, so we get a positive. So we know it's increasing before 0. Between 0 and 2, if I pick a number like 1, I get a positive and a negative. So that's negative, decreasing. And pick something like 5, positive, positive, increasing. So we are decreasing on 0 to 2. And that is because f prime of x is less than 0. Very easy to do. We've been doing that since the dawn of calculus. Right. All right, the last one I want to take a look at with you guys right now is number 6. Let's see here. They've given us the graph of velocity. Now we know that velocity is the derivative of position. All right. That might help us, I don't know. Of a car, traveling in a straight road for 35 seconds. The first question says, find the average acceleration of the car. This is not too hard to do. How do we get acceleration? Well, acceleration is your change in velocity over change in time. Use your AROC formula for this. People always ask me, how do you know it's average acceleration? How do you know it's AROC? Well, because my formula, I'm given velocity, I have to find my change in velocity. So I need my velocity at 35 minus my velocity at 0 over 35 minus 0. It's always our average rate of change. It's always our AROC formula pretty much. It's just how we go about solving it. We'll see an example like that, I think. Well, we may take a look at an example like that when we look at average value. So let's see here. So my velocity at 35 is right here, is at 30 it looks, minus my velocity at 0, which is 0 over 35. So we're going to get 30 over 35, and that is going to be feet per second squared, I think. Don't forget your units. Very easy to do. Part B. Find the approximation for the acceleration of the car at t equals 20. So now what they're looking for here, now they're looking for an instantaneous rate of change. But without a formula, I can't do that, but I can draw a line at 20. At 20, if I draw a tangent line, right? I'm going to use a tangent line here at 20, and I can estimate the slope. So again, I want my change in velocity over my change in time. So let's see here. If I go down, my change in velocity, I'm going down 10. I'm looking at this line right here, and I'm going to go over in time 5 seconds. So I got negative 2 feet per second squared. Now you may not have the same answer as me, but it's only an approximation. I just drew a tangent line there. Alright, for part C, they are saying approximate the area from 5 to 35 using a Riemann sum. Riemann, remember, loved rectangles, midpoints of 3 subintervals of equal length. And then explain the meaning. So let's take a look right here real quick. So Riemann sums, so I want to estimate the area from 5 to 35, v of t dt. So I'm going to use my Riemann sums from 5, they're counted by 5s, 10, 15, 20, 25, 30, and 35. So there's my first rectangle between 5 and 15, because I want 3 of them. My next one's going to become 15 to 25, and my next one from 25 to 35. Now, how do I know to go between 5 and 15? Because they're asking me to use a midpoint, and I don't know the midpoint between 5 and 10. I don't know the value up there. Too hard. So between 5 and 15, I know 10 is my midpoint, and they're telling me that has a height of 30. Between 15 and 25, my midpoint's at 20, and the height there is about 40. Don't forget your rectangles. Between 25 and 35, 30 is my midpoint, and the height looks to be back way down there at 20. So to get the area here, it's approximately, should use my squigglies. The first rectangle is going to be 10 by 30, or 10 by 30, plus 10 by 40, plus 10 by 20. And this is going to give us 300 plus 400 plus 200, which is 900. But let's talk units here. Okay, that's what they're asking for us. V of t, that is measured in feet per second. dt is in seconds. So this is feet. So this is the displacement the car traveled between 5 and 35 seconds. So it says between, you can write it this way, between 5 and 35 seconds, the car traveled 900, or whatever it is. So is it a car? I don't know. Yeah, the car traveled 900 feet from where it started. Alright, so I hope you enjoyed going over these. You still have question number 7 to do right here. Take a look at that one. And I hope you guys had fun, and I'll see you guys later. Bye-bye.